Ratios, fractions, and graphs is what we're going to look at in this video. So it's split into two parts. We're going to start off by looking at examples like this on the left, where we've been asked to express a ratio as a fraction, and then we're going to look at conversion graphs with ratios. So the way my videos work, I'm going to do the example on the left, which is I do. You are then going to press pause and have a quick example on the right, which is you do. So here we've been asked to express this ratio as a fraction. So we've got blue counters and red counters. So if I just write that out, we have red counters, we have blue counters in the ratio of 2 to 3. And in terms of writing this out as a fraction for blue counters, we can just write that as 3 out of 5. Where does the 5 come from? If you add these two together, you get 5. Altogether, there's 5 parts. So blue is going to be 2 out of 5. And if you wanted to know what red is, red will just be 2 out of 5. But for this question, they just asked for blue. So hopefully you've pressed pause and I've got an example on the right. So here we have green and we have yellow. In the ratio of 5 to 2, they've asked us for green, so that would be 5 out of a total of 7. And moving on, so here we've got 3 ratios, but it's the exact same principle. We've been asked for blue, so that is red, blue, green. That's 2 to 3 to 5. And looking at just blue, that will be 3 out of a total of 8, 9, 10. So the answer here is 3 out of 10. And again, hopefully you've pressed pause and had a go at this. So that is 1, 4, 7, and they've asked for red, so that would be 1 out of 7, 8, 9, 10, 11, 12. That's your answer there. So here's some practice questions. Press pause and have a go. Here are the answers. Mark your work. Now moving on, we're looking at conversion graphs. So here we've been asked to convert miles to kilometers using the ratio 5 to 8. So first we've been asked to draw this graph. So in order to draw this graph, we're going to first put the axis on. So just to save us a bit of time, I have already done that for us ahead of time. In fact, this doesn't actually match up quite perfectly as I thought it would. Does it? Oh, it almost does. Just have to make it a little bit bigger. So yeah, essentially you would do something like this. Perfect. That fits on more or less perfect. You would do something like this. You'd label the x-axis, you'd label the y-axis. So in terms of labeling them, we've been asked to convert miles to kilometers. So we can put miles down here. So we have miles. And then we can put kilometers here. We've been told the ratio is 5 to 8. So that means when miles is 5, kilometers is 8. So if I go down here, when miles is 5, kilometers is 8. So we're going to draw that like that there. So that point is going to go there. And you're always going to plot a point at 0, 0. So now that you've plotted these 2 points, you can draw a straight line through them. And that will tell you what the conversion graph looks like. Awesome. That is the conversion graph done. So then we've been asked to convert 10 kilometers to miles. Now you can use the graph to do this. So you can just go, well, 10 kilometers is here, draw a line across, read it down. The answer is roughly 6.2. Okay. You'll have a range in the mark scheme in the exam, so you don't have to be spot on. It'll give you a range where your answer can fall between 6.1 and 6.7, and anything between that would be right. And then we've been asked to convert 25 kilometers to miles. So now with 25 kilometers, you can see that's not really on the graph, so we can't read that. So instead, what we can do is we can just use what's given in the question. We have the ratio of 5 to 8. So we know that miles to kilometers is 5 to 8. The question is asking to convert 25 kilometers. Well, how do you go from 25 to 8? You times it by 3.125. So if I multiply this side by the same thing, that becomes 15.625. The way I did that is I found out how we went from here to here, and that was times 3.125, so I did the exact same there, and that gave me that number there. So looking at the example on the again, the exact same approach. Hopefully you started by drawing on the axis, and once you draw on the axis, let me just put that on here, and let me just make that a bit bigger so it does fit on. Perfect. Almost perfect. Let me just make that a little bit. There we go. I think that is about right. There we go. We've drawn the conversion graph. We need to draw that on. So that is 11 pounds would go down here. And I can see there's already a mistake here because that doesn't go to 11. So that's pounds and that's kg. Now on the x-axis, because it goes to 11, we can't go up in ones. So we'll have to go up in twos. So we go up in 2, 4, 6, 8, 10, 12, 14, 16, 18. And now if you read this off, £11 is 5 kg. So if I draw that on, we have £11 is 5 kg. That would be that. Plot your second point at 0, 0. Now that we've plotted 2 points, we can draw the conversion graph. And that would look like this. So again, 3 key bits here. Label the axis. Write down the axis properly like this. Make sure they go up by the right amount so you can fit them on. And then plot the point that's given by the ratio. And then plot 0, 0. And then draw your line. Now we've been asked to convert 12 kg to pounds. So 12 kg. Again, the graph just isn't big enough to fit that. So instead, we can just use the ratio that's given in the question. So we know from the question. And if the ratio wasn't given in the question and you just had the graph, you would just do half of that. So because you've got 12 and you can't read 12, can you read half of 12? Yes, you can. Because you can read half of this, you would just double your answer. So I know the answer is just going to be double of 13, roughly. So if we just use the ratio in the question, we have 11. In fact, we won't use the ratio in the question. For this one, we'll just use the graph. So if I just use 6 kg, go straight across, come down, and you can see that's roughly 13. So I can see from here for II, all right, II here, I can see that 6 kg is roughly 13 lb. Now the question asks you for 12, so I just double it. So 12 kg will be 26 lb. And again, the mark scheme will have a range between, say, 24 and 29, so anything in that range is about right. And then if I come on to III, I've been asked to convert £30 to kg. Now again, we can't really go up to £30, but what we can do instead is we can find what £10 is and times it by 3. So I know £10 is 4.5. So I know that 10 lb is 4.5 kg. So 30 lb must just be 4.5 times 3, which is 13.5 kg. So here's some practice questions. Press pause and have a go. Here are the answers. Now with the answers, like I said, there will be a slight range on these questions when you're reading off the graph. Now, if you would like some more practice on this, I have got a full worksheet over on the website. Do check it out. And if you found this video useful, I've got loads of other content like this on my channel. Do check it out.